We started our discussion on polynomials in the previous video, and we had seen some basic definitions and terminology with regards to polynomials. Let us now do some exercise problems to reinforce those ideas and make sure we have a clear understanding of those definitions and terminology. Okay, so let us do the first problem from the exercise, which is exercise 2.1. And which of the following statements, following expressions are polynomials in one variable and which are not? Okay, and we have to give reasons for our answers. So let's start with each of these algebraic expressions and see whether they satisfy the rules of being a polynomial or not. And we are specifically asked whether these are polynomials in one variable or not. So the first one, 4x squared minus 3x plus 7. So clearly the only variable present in this algebraic expression is the variable x. So we have x is the only symbol that is present here. So it is an algebraic expression in one variable, but is it also a polynomial? And if you remember, the one of the rules for the algebraic expression to be a polynomial is that the exponents or the powers of the variable must be whole numbers. So clearly here the power of x here is 2 in the first term. In the second term, the power of x is 1, that is 3x power 1. And in the third term, for the constant, we know the constant term corresponds to x power 0. It is 7 into x power 0. X power 0 is 1, so 7 into 1 is 7. So clearly, it is an expression in one variable, and it satisfies the condition for being a polynomial in the sense that all the exponents for the variable are whole numbers, 2, 1 and 0. So therefore this is a polynomial in one variable. So the first one, 4x squared minus 3x plus 7, is a polynomial in one variable. So we have mentioned that now it is indeed a polynomial in one variable, and that variable is x. And the reason why it is a polynomial is because all the powers of the variable are whole numbers, so it is a polynomial. Let's look at this second expression, y squared plus root 2. The variable here is y, so the only variable present here is y, and the power of that variable is 2, which is a whole number. We have a root 2 here. Root 2 is 2 power half, but there is no y involved here, so it is the constant term. So it is we can write that as y power 0. So we can write this expression as y squared plus root 2 times y power 0. So we clearly see that it is an algebraic expression in only one variable, which is y, and the powers of both the variable y is 2 and 0. So for the first term, the exponent is 2, and for the second term, the exponent is 0. Root 2, which is 2 power half, that is we are not concerned about the power of the number. We are concerned only about the power of the variable. Okay, if the power of the variable is not a whole number, then it is not a polynomial. In this case, the two terms have the powers of the variable y as 2 and 0, which are both whole numbers. So therefore it is also a polynomial in one variable, which is y, and since all the powers of the variable y are whole numbers, it is indeed a polynomial. Okay, so we have stated that. Okay, that's a polynomial in a single variable y, and all the powers of that variable y are whole numbers. Now let's move on to the third expression, 3 root t plus t root 2. So we can write this as 3 root t is 3 into t power half. Root t is t power half, plus the t root 2, we can write it as root 2t. So basically we have this to be an algebraic expression with only one variable. The variable is t, but one of the powers of the variable is not a whole number. We have t power half here. The root t corresponds to t power half. So the power or exponent of the variable here is half, and the exponent of the variable in the second term is t power 1. So for this expression to be a polynomial, all the powers need to be whole numbers. However, in this case, one of the power is not a whole number, and therefore this is not a polynomial. It is an algebraic expression in one variable, which is t, but since one of the powers is not a whole number, it is not a polynomial. So we will say that it is not a polynomial because one of the powers is not a whole number. So we clearly see in this expression, okay, t power half, the power of this particular t, the first term, is not a whole number, and therefore it is not a polynomial. Okay, the second term is satisfying the condition for the polynomial. However, the first term is not satisfying. It has a power which is not a whole number. The second term has a power of 1, which is a whole number, but even if one term is having a power that is not a whole number, then that expression is not a polynomial. Okay, let us move on to the fourth expression, which is y plus 2 by y, and let us see if this is an expression that can be called as a polynomial in one variable. So we can rewrite this expression 2 by y. When we bring the y to the numerator, we can write that as y plus 2, bring the y to the numerator, so it becomes y power minus 1. So basically we have y power 1 here plus 2 y power minus 1. It is an expression in only one variable, y. However, one of the terms has a power which is not a whole number. It is a power of minus 1. So minus 1 is not a whole number. Whole numbers start from 0 and go on to have all integer values, all positive integer values, including 0. But negative numbers do not come under whole numbers. So therefore, this expression is not a polynomial, even though it is an expression in one variable. But we cannot call it as a polynomial because this term violates the condition that the powers should only be whole numbers. Minus 1 is not a whole number, so therefore it is not a polynomial. Okay, so 2y power minus 1 is a term whose power is minus 1, and minus 1 is not a whole number, and therefore it is not a polynomial. Coming to the fifth expression, x power 10 plus y power 3 plus t power 50. Clearly all the terms have a power which are whole numbers. So 10 is a whole number, the power of y is 3, that's also a whole number, and the power of t is 50, that's also a whole number. However, we have three variables. We have variable x, we have variable y, and we have a third variable t. So this is a polynomial, but it is not a polynomial in one variable. And if you look at the question, it clearly says which of the expressions are polynomials in one variable. So this one is not a polynomial in one variable. It is a polynomial in three variables. Okay, so clearly we can see that this is a polynomial in three variables, but it is not a polynomial in one variable. Okay, now let's go to the second question. Write the coefficients of x square, x power 2 in each of the following. So we want to find what is the coefficient of the x power 2 term in all these expressions. So let's go one by one. For the first expression, 2 plus x squared plus x. So the coefficient is the number that is multiplying this term x squared. So the number in front of this is 1. So if there is no number, it means it is 1. And if it's with a negative sign without a number, then it means the coefficient is minus 1. So this is basically 2 plus 1x squared plus 1x. So the 1, we don't write it. So it is understood that the coefficient in this case is 1. Okay, for the x squared term, the coefficient is 1. So let's write that. I'll just write coefficient of x squared is 1. Okay, for the second expression, which is here, we have 2 minus x squared plus x cubed. So again, it is because it's a minus and without a number in front, it means there is a 1 there. So minus into 1, so it's a minus 1. So the coefficient of x squared in this case here is going to be minus 1. It is basically 2 minus 1x squared plus 1x cubed. So the coefficient of x squared in this expression is going to be minus 1. Coefficient of x squared is minus 1. Now let's look at the third expression here. We have pi upon 2 x squared plus x. So the coefficient is nothing but whatever number is multiplying the term of x squared, that is the coefficient. So the coefficient of x squared is pi by 2 and the coefficient of x is simply 1. So we want the coefficient of x squared, so therefore it is simply pi over 2. So let's write that. So coefficient of x squared is pi over 2. Okay, now let's come to the last expression, root 2x minus 1. Clearly, we don't see any x squared term in this particular expression. There is no x squared term here. So if we want to include an x squared term, we can write it as 0x squared. So 0 into x squared is 0 plus root 2x minus 1. So the coefficient of x squared, because x squared does not exist in this expression, it means that the coefficient of x squared is basically 0. So 0x squared, there is 0 quantities of x squared terms in this expression, and the coefficient of x is root 2 and the coefficient of x power 0 is minus 1. So the coefficient of x power 2 is basically 0 here. So we can write that as the coefficient of x squared is 0. Okay, so when we have an expression in which a particular exponent term is missing in the expression, it means that the coefficient of that particular term is 0. Okay, since x squared does not exist in this expression, it means that the coefficient of x squared is 0. Similarly, if we had to find the coefficient of x power 3 or x power 4 in this expression, all those coefficients are 0. X power 3 has a coefficient of 0, x power 4, 5, and everything. Each of them has a coefficient of 0. That means this expression has a non-zero coefficient only for x power 1 and x power 0. Okay, all the other terms of x have a coefficient equal to 0. So in this particular case, specifically for the coefficient of x squared, it is 0. Now let's move on to the next question. We are asked to give one example each of a binomial of degree 35 and a monomial of degree 100. So what is the meaning of binomial? Binomial is a polynomial which contains only two terms, and we want a polynomial which contains two terms and the degree should be 35. Degree is the highest exponent or the highest power of the variable. So binomial of degree 35, so we can write this as, let me write that clearly, binomial of degree 35. So we want degree 35, so we can put some x power 35. So the variable is x. We can make it y also, y power 35 or t power 35, whatever variable we want to choose. So x power 35, so the highest degree should be 35 because we want degree to be 35, and we want this to be a binomial. That means we need two terms. So we have one term already here, so we need to include one more term. We can put plus or minus, whatever we want, and put another term whose exponent or power is less than 35. Anything from 34 to 0, so we can just put a constant, x power 35 plus 5 or just plus x, whatever, right? That's one example. Or we could have put x power 35 minus 2x squared, or x power 35 minus 45, whatever, right? So basically we need two terms and we need the highest power to be 35, and we can make many different combinations of this to satisfy this given condition. Okay, so I've given you two examples. We can make many examples of this to show a binomial of degree 35. Next we have a monomial of degree 100. So the second part of the question is we need a monomial of degree 100. And again, what is a monomial? It is a polynomial that contains only one term. Just as in the binomial we have two terms, in a monomial we have only one term. So let's write that. Monomial of degree 100. Monomial means we have only one term, so x power 100. So we want the degree to be 100, so we can have it as x power 100, or we can have some other variable like y power 100 or t power 100, whatever is our variable, and it has only one term, so that one term will be the variable power 100. That's it. Okay, no other terms to be included here. So that's a monomial of degree 100, and I've given you 3 different examples for that. Okay, now coming to the next question, we have to find the degree for each of the following polynomials. So again, the definition for degree is it is the highest power of the variable in the given polynomial expression. So what is the highest power in each of these expressions? So for this first expression, for the first polynomial, 5x power 3 plus 4x squared plus 7x, the highest power is 3. So for the variable x, the highest exponent is the number 3. And therefore the degree here is 3. Okay, now let's look at the second expression, the second polynomial. We have a polynomial in the variable y, and the highest power of the variable is 2. So therefore the degree of this polynomial is going to be 2. So y square is the only term with the variable, so the highest power for the variable is 2, therefore the degree of this polynomial is 2. So let's write that down. Degree equals 2. And what about the third expression? We have 5t minus root 7, so the variable is t, and the highest power of that variable is t power 1. So this is a polynomial of degree 1. So there's no other t term in this, and the highest power for that t, that's a single term that we have with t, so the power of that t is 1. Okay, if there is no power, it means the power is 1. So the highest power is that single term's power, which is 1. Therefore the degree is equals 1. Okay, so that's a polynomial with degree 1. And finally, for the last one, which is a constant polynomial, it is a non-zero constant polynomial. We can write that as the constant time, that's 3x power 0 or 3y power 0 or 3t power 0. So that means the power or the exponent of the variable is 0. So therefore the highest power of the expression of the polynomial is 0. So this is a degree 0 polynomial. So degree equals 0. Okay, so we could have used any variable of our choice, x or y or z or t or u, whatever. Either way, the power of the variable is going to be 0, and the highest power is 0, and therefore the degree is going to be 0. Okay, let's move on to the next question, and we have to classify each of the following expressions as either being linear, quadratic, or cubic polynomials. So we have to recall what is a linear polynomial, what is a quadratic polynomial, and what is a cubic polynomial. A polynomial is a linear polynomial if its degree is equal to 1. If the degree of the polynomial is 2, we call it as a quadratic polynomial, and if the degree is 3, we call it as a cubic polynomial. So with that definition, we can clearly classify each of these as being either linear or quadratic or cubic. And by the way, degree is the highest degree of the polynomial. So if we look at the first expression here, the highest degree is 2. So therefore it is a degree 2 polynomial, and degree 2 polynomial means it's a quadratic polynomial. So this is degree equals 2, and therefore it is a quadratic polynomial. Okay, now let's look at the second example, the highest power in this expression is 3. So that means the degree of this polynomial is 3. So we'll write this as degree equals 3, and therefore for a degree 3 polynomial we call it as a cubic polynomial. So this is a cubic polynomial. Let's come to the third expression here. We have y plus y squared plus 4. So the highest power here again is 2, which is coming for y squared. This is y power 1 plus y power 2 plus 4 y power 0. So the highest power is 2. Therefore, it means that the degree of this polynomial is 2. So degree equals 2. And therefore, we can classify this as being a quadratic polynomial. How about the fourth one? We have 1 plus x. The highest degree is 1. So if the highest degree is 1, the highest power is 1, that means the degree of the polynomial is 1, and degree 1 polynomial is called as a linear polynomial. So therefore, this is a linear polynomial. How about the fifth one, 3t? Again, this is a polynomial in the variable t, and the highest power for the variable is 1. It is t power 1. So that corresponds to the degree being 1. So that means degree equals 1, and therefore it is also a linear polynomial. Okay, now we have the sixth one. This is a polynomial in the variable r, and the variable has a power of 2. So the highest power for this particular expression is 2. So since it's r squared, the highest power is 2. That means the degree of this polynomial is 2, and degree 2 polynomial means it's a quadratic polynomial. And finally, we have 7x power 3, so 7x cubed. So the only variable here is x, and the highest power for the x is 3. So that means the highest power gives us the degree of the polynomial. So the degree here, degree equals 3, and therefore this is a cubic polynomial. Okay, so we have seen in the previous video some basic definitions and terminology related to polynomials, and in this video we have done an exercise where we have done examples based on those definitions and terminology regarding polynomials. And now I hope that you will have a much clearer understanding of those terms and definitions, because you need to be very clear about it, because as we go on further we will be using these definitions as if it's in the background of our mind. Okay, and we need to be very clear about these concepts. And we'll finish here for today, and we'll continue in the next lecture with the next topics in the chapter of polynomials.